All right. Well, thank you guys so much for joining with us and being patient as we got today started off. My name is Lynn. I am a customer service rep here at WarmlyYours, and today I am joined by the illustrious.
Scott from WarmlyYours. Thank you for joining us.
Absolutely, guys. Today we're talking about snow melting for asphalt driveways. So if you have any questions on the webinar today, feel free to ask. You can do so in the chat feature. Just if we don't see it right away, we'll definitely get to it by the end of the presentation. So feel free to ask away, and we'd be happy to help out. So today, like I said, we're talking about our snow melting systems, specifically for underneath asphalt. We're going to be talking about the different system options available to you, and then we're going to go over some project examples. We're going to show an example of a full coverage driveway, as well as all the installation steps and controls that are used there. And then we're also going to show an example of a tire track coverage as well. So first off, electric snow melting systems are designed to be embedded in concrete, asphalt, mortar, sand, anything like that. So you don't want them to be, they're not going to lay on top of the driveway or anything like that. They need to be fully embedded. And what they do is as they heat up, they evenly heat that surface so that the snow and ice melts away. And we have lots of different options available for controls and sensors and things like that so that you can actually really automate it to your needs and how you plan to use the system. So, Scott, were you at this job site or were you doing this one?
I did this one, yeah.
Yeah, I thought so. So, can you kind of tell us, what are some things to think about when doing snow melting with asphalt?
Well, you're going to have two layers of asphalt. The number one question we get is my asphalt installer only wants to do one layer, and they want to do a 3-inch layer on top of gravel or on top of something. One thing to keep in mind that we another question we get a lot is there a weight limit for your product? Like, can we drive anything over this that we want to? Once it's installed, it doesn't really support any weight. It's the asphalt or the concrete around it that supports the weight. So your car is not pushing down on the cable, it's pushing down on the concrete that surrounds or the asphalt that surrounds it. Now, if you make that layer of concrete too thin, if you do one layer of asphalt that's too thin and you drive over it and all of a sudden you have great big ruts in that asphalt and all of a sudden that asphalt fails, well, when the asphalt fails, the failing asphalt can damage the cable that's inside of it, that's put in there. So it's not the weight limit of the heating product, it's the weight limit of the surface. So you want to make sure you have a very good surface installed above or surrounding the heating cable. And a single layer of thin asphalt isn't going to do that, nor is a insufficient thickness of concrete with an insufficient subsoil going to support the weight, because the concrete will break, the asphalt will break, it'll fail, and when it fails, it'll take the cable along with it. So that's what you really have to worry about, is the integrity of the asphalt or the integrity of the concrete. A lot of people want to say, hey, can I just put can I put some new cables on top of my old asphalt driveway and then just cover it with a new layer of asphalt? Well, you can in theory if that lower level is in good shape, but usually people aren't replacing an asphalt driveway that's in good shape. They're replacing an asphalt driveway that's failing, that's getting bad. And you don't want to be putting a good layer of asphalt on top of a bad layer of asphalt, because it'll fail too, just like the layer below it. So the most important thing is you have to make sure you have a good installation. You have to make sure that the layers are correct. And the differences between electric heating versus water heating is that the National Electric Code and local codes have specific rules about where that cable is, what it's surrounded by, and that sort of thing, to make it code compliant. So that's the same reason why you can't use gravel. We get the question all the time, can I put this in a gravel driveway? No, you can't, because it's not going to pass the National Electric Code. It has to be a hard surface, and it has to be cementitious, which is usually cement or asphalt or something that's non-combustible. That's why this product can't go on roofs, is because it needs to be 2 inches above a combustible surface, and there has to be an 1.5 inch cover on top of it. So you're looking at 3.5 to 4 inches of non-combustible surface combined. So there's a lot of different things to think about. But the good thing is our installation instructions and our cross sections all have that figured out for you, how to give you the best results and how to give you compliant results that your electrical inspector is going to come in and go, oh yeah, I see that's all good. That's all good. So, okay, checks it off and you're ready to go. So those are the things that when we send out a cross section or send the installation manual, the code compliance with the National Electric Code is already figured out, and the thicknesses and the layers are already figured out to industry standards to make sure that you have a good system that doesn't fail and a good and you don't have any failures resulting from a failed asphalt job or a failed concrete job. So yeah, there's a lot of different things you want to do with asphalt and with concrete. We're going to talk about them both today.
Yes, absolutely. And we have systems that have gone in driveways, years and years ago. And I always kind of say, as long as the driveway is installed correctly and it's a good product, the system is going to pretty much keep working. We run into more issues with, trying to put new asphalt on top of cracking asphalt or something like that.
Right, exactly. I worked in an old place. One of the old places I worked had a hot water system in a concrete drive or in a concrete parking lot. Also, where the trucks came in and out. Well, what happened is eventually the trucks going over the concrete started to crack up, and then eventually, after the concrete cracked up,
Yeah.
you could go out there and you could lift the pieces up, and you'd see the remnants of old hot water tubes under there. So you can see how as
Yeah.
the aggregate starts to break up, it exposes the wire or the tubes or whatever it is, and that's why the system's only as strong as what's above it.
Yes, absolutely. Change. There we go. So looking at some different coverage options, like I said, we're going to show two different projects, one with full coverage and then the other with tire tracks. And full coverage is pretty self-explanatory. Basically, the entire area or the majority of the area of the driveway, walkway, whatever you're doing, is going to be fully covered. Now, for driveways, a lot of times, especially if they're especially large or especially long, it's nice to not have to heat the entire thing. You can just do tire tracks to kind of get in and out.
Right. It also has to do with power. You
Yes.
invariably, people that have never even thought about heating their driveway say, hey, you know what? I'm going to get a new driveway. Let's see what it would cost to heat the entire thing. Well, once they see it's not necessarily the cost to heat the entire thing, it's the amount of power it takes to heat the entire thing. So it does take, we average around 50 watts per square foot. So you start multiplying that by the number of square feet,
Gets up there.
it gets up there. And what happens is these people will sometimes say, that's too many amps. I don't have that much space in my breaker box. Well, that's one thing you have to do is you have to look in your breaker box and see if there's any available space there to begin with. Because if your breaker box is full and you don't have any open spaces, you're not going to be able to heat your driveway unless you get a new surface. So that's one thing. The first thing you want to do when you're looking to get one of these jobs done is go look in your breaker panel, get an idea of the number of amps you have. And then what you can say is, I have this size of driveway. I have this many amps to use. What do I do? And 9 times out of 10, it's going to end up being tire tracks to get you in and out. That way you can get in and out, and then you don't have to worry about all that extra power that you're going to need.
Yes, definitely. Yeah, that's always something to consider as well. So looking at, I love these cross sections. This is a really good one showing asphalt, and this I think shows that double pour that you were talking about very well, Scott. Can you kind of walk us through it?
Yeah, you have to have the base coat done because you're not going to be driving a paving machine over the top of the cable. You can use the paving machine on the base coat. So that's where you're going to put your base coat down. You're going to roll over it with a roller, and you're going to compact that over the gravel. And that is where you're going to lay the snow melting mats or the cables. 99 times out of 100, it'll be mats. Just because of the timing and the ballet that you have to do around the day of the paving. So you need to make sure you have a good gravel, and you're not doing one pour of asphalt here. It's two: the base coat, then you're putting down the snow melting mats, and then you're going to be applying asphalt over the top of it to a thickness of 2 inches, because the National Electric Code says you have to have at least 1.5 inches on top to comply with code. So you're going to be doing a 2-inch layer on top, but you're not driving a paving machine over the snow melting mats. You're going to be doing that in a different method. So that's one thing to keep in mind. So first thing is, when you're talking to a pavement company, this is the way you want it to be done. You're going to say, here's what it looks like. This is how we need to do it. And they'll go, okay.
Yeah. They'll just say, okay, they won't have a single problem with doing
Right.
a double pour. So looking at the full coverage example, oh, if I can go the right way. So this one, obviously, like you said, uses mats. Can you give us a real brief overview of why we'd be using mats with asphalt versus cable?
Because when you're doing an asphalt driveway, usually it's being done on one day with 1 or 2 trucks. So a truck comes in, it pours the asphalt into the asphalt paving machine, and it drives over your driveway, and it puts down that 2-inch layer of asphalt, and then it gets rolled over. At that point, they are going to sit around and wait, trying to keep the asphalt warm enough that it can be installed, and they're going to wait for you to put the cables on top. Well, the cables, if you have to manually string them back and forth, they are not going to have enough time. They're not going to be able to wait for you to string those cables back and forth. They're going to say, you need to speed that up a little bit. And that's what's so great about the snow melting rolls or the mats, is that the wire's already pre-attached to them. You just roll them out, and then you can dump asphalt on them. Roll them out, dump asphalt on top of them, roll them out. So you're moving quickly. You're getting that asphalt down on the surface while it's still hot. So that's why, as I said before, 99 times out of 100, you're going to be using the snow melt mats or the rolls.
Absolutely. And we have pictures of that kind of showing how they roll them out and everything like that. So the power requirements, as we said, can be pretty great. So you want to make sure that you are looking at, what your available power is. Obviously, this one, the total amperage was about 88 amps, about 21,000 watts. So we'll actually tell you too in your SmartPlan, and as we're helping you begin planning out the project, specifically what breakers you need for these projects or for this specific project. So you can actually see that we have the dedicated heating circuits as well as a non-dedicated or a non-GFI rather circuit for the control.
Yeah, and we're all, if you notice, the heated area is always going to be smaller than the total area, because you can never ever cut the heating cable. So you can't order too much and then cut it to size. You have to get the correct amount. And that's why it's so important for you to get us the dimensions of your area and the electrical that you have. That way we can get you the correct size and also supply you with the smart installation plan, which we're going to take a look at in a little bit.
Yes, absolutely. And one more thing I want to touch on is the operating cost, mainly because I did the operating cost daily training today, so I've been thinking about it all day. And you can kind of see, I think that there's a common misconception that there is it's very expensive to run these. And generally, again, obviously, depending on the power requirements, it's not going to be insanely expensive. And especially if you're comparing it to, shoveling for yourself or getting a plow to come out, something like that. So for this, you're looking at about $2.13 per hour for the upcoming project. And
And,
this is the smart plan.
and the thing is, it's usually costs a little bit less than having somebody come out and plow.
Yes.
Each snowfall that comes out. Now, obviously, there are snowfalls that are going to be 1/8 of an inch, and there are going to be snowfalls that are 36 inches or 48 inches. Those
I'd
are
say it.
those are off the, they're off the I'm looking for the bell curve. They're going to be at
Yes.
the
I
far
was going to say the
end. Yeah,
spectrum. Yeah,
yeah,
something like that.
yeah. I'm a bell curve guy. So you've got these two things. Most stuff happens here, but you will have a lot of snow or a little tiny bit of snow, and those are just going to be aberrations. So, but this smart plan here shows exactly how the product is to be laid out. And if you look here, these are a lot of full mats, like there's 20 foot, 20 foot, 20 foot. There are also some longer ones that are just have one cut and turn. That means that this is a very quick installation as you go, because you can lay this out cover it, lay some more out, cover it. You're not trying to string cables back and forth over this 24-foot by whatever that is, 24-foot by 20-foot driveway. So that's going to speed your installation up and make it so the asphalt is actually hot when it goes down.
Absolutely. And actually, I want to go back real quick. I meant to point it out. One of these slides here, this guy actually has the smart plan printed out right there. And I like that you can actually see, like, this is exactly where he knows where these cables are, where the mats are. It's going to make it a much safer and easier installation for everybody.
Yep.
So, Scott, this is a little bit more your domain. Can you kind of tell us about testing that snow melting system?
Well, testing is done by the electrician. So let's talk about what an electrician's job is during this installation. An electrician's job is not to show up after it's been installed and start hooking it up. The electrician is actually there first. The electrician is there and he's following the smart plan and seeing where the locations of the junction boxes have to be. Then he plans out where that junction box is going to be. Then he's going to need to get conduit from the house or from wherever the building is to that junction box. And there could be 2 or 3 different junction boxes because the cold leads are only 20 feet long. They're only long enough to get from the heating mat into a junction box. So you need to keep that in mind. The electrician needs to know that. That's why you give them the installation plan, because the plan will show where the junction box is and where it's assumed that those wires are all going to go together into the spaghetti bowl that we call it. Then he needs to get the proper pipe to get from the house to the junction box and the proper pipe to get from the junction box into the asphalt, because the non-heating leads are not rated for direct burial, which means they can't go in the dirt. And the National Electric Code states that they must be protected as they leave from the surface, which means the conduit actually has to be stubbed into the location of the driveway, then covered. So the electrician has to have that all done before the asphalt people even show up. So not only are they going to be there a day or 2 ahead of time, getting all their conduit bent, cut, lengthened, in junction boxes installed, all that stuff has to be done in advance. Then during the installation, before the installation, he's testing the cables with the mega ohm meter, which is not an ohm meter, but it's a mega ohm meter, which actually what it does is it sends 500 volts down the line to make sure that there's 3 wires inside that heating product, that green cable. There's 3 wires. 2 of them heat up, 2 of them make a circuit, and 1 of them's a ground. So what it does is it tests across the ground and one of those heaters to make sure that the installation is good, that the power doesn't jump from ground to that wire. Then they do the exact same thing going from the ground to this second wire to make sure that the ground and that second wire don't have any connection between them. So that's what a mega ohm meter does. And that's why they need to do it before it's installed, while they're laying the product out on the installation, test it then. And then after they're done, it needs to be tested. So that electrician also needs to have a mega ohm meter with them. They're fairly common. A lot of electricians have them. It's not some mysterious thing that costs $1 zillion. They're fairly inexpensive, but it's going to be needed.
Absolutely. Yeah, it's the kind of thing, if they don't have it, they know somebody who does for sure.
Right. Yep.
So this is another, I like these cross sections as well, actually showing the 2 layers. Again, you can see the crushed aggregate or that like kind of gravel base layer. Then there's that base asphalt layer, the snow melting system, and then obviously, again, like you said, the finished asphalt, doing it in 2 pours.
Right.
And then again, kind of just touching on the gravel layer, making sure that it's, definitely going to hold up. 4 to 8 inches is usually what we recommend. But you can go up to 12 inches for, really high traffic areas, maybe somewhere like that parking lot you were talking about.
Mm-hmm.
And then you can actually see it in action. So can you kind of walk us through this?
Yeah, so the base layer there was actually this job, the base layer was done a few days ahead of time. That's why it looks kind of dirty. Well, it's because everybody's been walking over the top of it, but that is the base layer. That's a new pour of base layer. And then you can see what happens is the paving machine was used to do the base layer. That's what you lay the base layer down with, is a paver. Then what happens is you have the mats go on top, and then a high boy or a lift truck or whatever will come over and dump asphalt, hot asphalt on top of the mats as they're laid out on the base coat. And then the guys will come there and work by hand over the top of it. And then they'll lay another piece of that cable down. They'll dump more asphalt on the top of it, working their way from the garage back to the road. That way, you never, ever have a machine drive over the heating wire, ever. So that's what they're doing here. It started, you can see, if you look back there in that back corner on the top picture, you can see the roller back there in the garage. And that's because they've worked their way from the garage and they're working their way out to the driveway, allowing them to pour, put the mat down, pour, put the mat down, pour. And then once they get it all poured and covered, then they will come through with that. You can see that that high boy there in the back.
There we go. Sorry, I clicked something.
So one of the things with this, if you can go to the next page, we can take a look at what's happened here. Is you can see in the lower right-hand corner, you can see where the mats have already been pre-cut and they're laying on the ground next to it. So we're not even doing our cuts and turns. The asphalt guys are not waiting for us to do our cuts and turns. We've already got them done. And all we do is once the cuts and turns are done, we just take them and we move them onto the asphalt binder coat, and then we cover it. And then the next row is ready to go there, is cut. You can see out by the street. There's the next one ready to go there on the ground. And you can see the electrician's already been there because at the bottom center, you can see the junction box there and conduit. And that's all been put there ahead of time because we're pulling the cables, we're pulling the non-heating leads into that box to make our connections with the power coming from the house. But that's exactly how you do it. You lay the product out, that lift comes and drops the asphalt on top. The people work it with their hands, and then the roller comes out.
Perfect. Scott, when I like gesture with my mouse, can you see that on your
I
end?
sure can.
Okay.
Yep.
Just wanted to make sure I wasn't doing that for no reason. All right. So this is actually going to show that that high boy and everything like you were talking about, Scott. So I like this video. I always think it looks like did you ever play with Floam or see Floam?
Yes. Yeah. Mm-hmm.
But except that it's, really hot and will burn you. But it's like the forbidden Floam.
Yeah. All you have to do is just remember you touch that stuff once when they're pouring it out like that, and you'll see how hot it is.
Yes.
Really hot.
So moving on, and as you can see that it tends to go relatively quickly. If everything is, laid out ahead of time, ready to go, you can make your asphalt guy's job very easy if you need to.
Yeah, I'd like you to go back to that page real
Yeah.
quick, that page again. And as soon as you start talking about them not being able to use the paver over the top surface,
Yeah.
people start to think, oh no, we're going to have to carry asphalt by hand. We're going to have to get wheelbarrows. We're going to have to do all this. You don't have to. It's very, very easy. That's why you start at the furthest point away from the road and you work your way out. And that way you can get it done and you're not using any wheelbarrows. There are no wheelbarrows were injured during the filming of this video.
Good to know. So this is the spaghetti bowl we were talking about, and this is where the cold leads are going to be coming from the mats over to the junction box, and then the splices or extensions will be made, and you need to make them all in this box according to National Electric Code, correct?
Correct. And that's where your connections are made by the electrician. They're going to figure out what size wire to provide out to that box because of amp draw and the amount of distance from where the power is coming. So that's called a voltage drop. So they're going to do that figure. The more voltage drop you have, the thicker the wire has to get. So they're going to be figuring all of that out. They're going to be doing that. And they're also going to be testing it again at this point. While these are all exposed, they're going to be testing it with that mega ohm meter.
Yeah, make sure that nothing got damaged during that second pour.
Mm-hmm.
So, kind of getting into the controls and sensors that we have available, we have a lot of different options to really customize the systems to how you want to use them and what's going to really work best for you day to day. So, this actually utilized our premium control, and it had that aerial sensor. So, you can actually see this is the control and the aerial sensor with a little snowflake on it. And then, of course, we have our plaque That is also according to National Electric Code, just to make sure that if anyone works on the driveway in the future, they're aware that there's an electric system. So, Scott, can you kind of tell us about the, hold on feature, some of the features of the controls
Well, the reason
for this control?
why this was chosen is because it has a sensor that gets buried in the asphalt, so it doesn't exceed a certain temperature. Asphalt is much more prone to break down if it gets too hot than concrete. You can get concrete as hot as you want it. They put concrete under rockets because it really doesn't, it's not damaged by heat really. But asphalt, you'd never put asphalt underneath a rocket. SpaceX would never say, hey, go pave that area with asphalt. We're going to shoot a rocket off of it, because the whole thing would just
Turn into soup.
disintegrate. Yeah,
Yeah.
it would turn to soup. Exactly. And that's why you have this control, because the sensor that goes in, and if it gets above 80 or 90 or whatever you want to set it to, it'll turn off because it's hot enough that the snow is going to melt anyway. It doesn't need to be on any longer. Some states like New York and Rhode Island and others in our United States, they have specific rules relating to whether it's concrete or asphalt or anything. If the slab gets to a certain temperature, the unit should turn off, because after a certain temperature, snow is not going to stick to it anyway. It's going to melt. So that's what that is. And the hold on time, there's two phases of a snow event, right? Well, there's actually three phases. One is when it starts. That's going to be hitting the sensor. The sensor is going to say, hey, it's below 38 degrees, which is the threshold temperature. And now I feel snow. So we need to turn the system on. So that's going to be the start. And then the sensor will continue to send that signal to the control until it either stops snowing, so the sensor on top is not getting any snow on it anymore, or the temperature of the air has gone above 38 degrees, because if it's above 38 degrees, the snow is not going to stick anyway. So that's what the sensor is telling this control. So that's the first two: start and then stop. Then the thing is, the system will continue to run afterwards to melt what was deposited on the surface. So that could either be 1 hour, 2 hour, 3 hour, 10 hours, whatever it is. And no two snows are exactly the same. And when a person gets a system the first year, we don't know where to tell them to set it, because we don't know what their snow is like. We don't know, no year is the same. That's why there's a bunch of different ranges on snow reports, because this area always gets 12 inches of snow per year, every single, it doesn't happen that way. So sometimes they may have to turn the after run on longer to make that period of when the sensor says, hey, it stopped snowing. Now it's the time to melt the snow and then turn it to water, and then also make that water evaporate into the air to make you get a nice, clean, dry, completely clean surface with no black ice, no embedded snow that's down inside the asphalt. So that's what that's designed to do. Sometimes 10 hours is too long. Sometimes 10 hours is not enough, especially if you got 48 inches of snow. So you may have to turn that, the hold on time, to continue to melt and evaporate. You just don't want it to melt and turn to slush. You want
It's an
it
ice
to,
rink.
yeah. So you want it to turn it off. You want it to melt the snow and then evaporate it. And that's why if you drive by somebody's house in the wintertime and you see that their driveway is completely void of snow, meanwhile the neighbor has 10 inches of snow on their driveway, they have a heated drive.
Oh yeah. Yeah, you can always tell.
Exactly.
So this is actually kind of showing, like you talked about, the full job of the electrician. So essentially taking power from that breaker panel all the way out to those mats. Can you kind of walk us through step by step what you're looking at here?
Yeah, there's inside and there's outside. The outside portions belong outside and the indoor portions belong inside. There's no mix or match here with this particular control. The sensor, the aerial mounted sensor, actually is outdoors, so snow can hit it. That's a novel concept, I know, but it does have to go outside for it to work. And then the high temperature limit sensor needs to be embedded in the asphalt. Those are the things that are outside. The junction box, we've already seen the junction box where it's put outside. And obviously the heater cables need to be outside, because that product should never be used indoors. That product is for outdoors. The heater cable or the mat, that is never to go inside. It goes outdoors. So let's take a look at what's to the left, and that is the relay panel. The relay panels have to go inside because the box is not rated to go outside. And if you stick a relay panel outside, it will rust, it'll let water in, and it'll cause the relays to fail. It's a NEMA 1 enclosure, which means indoors. And any electrician worth their salt should see that on the door where it says NEMA 1. They should go, oh, this needs to go indoors. Surprisingly, that doesn't happen every time, but that's why we're here today, is to say that those relay panels go inside. The controller, if you look at the label, it says it's a NEMA 3X or a NEMA 4, which means outdoors. However, why would you put this box outdoors to make your customer have to, if they want to manually turn it on or manually turn it off? I've got an idea. We don't like this customer. We're going to get even with them. We're going to put the control outdoors, so they have to go outside to turn it on, or they have to go outside to turn it off.
That actually would be kind of evil, like just that petty amount of evil. That's really funny.
Exactly. That's what do they call that? Very passive aggressive.
Yes.
We're going to
But
stick that.
ideally, the control should be inside.
Yeah, we're going to make them pay for that every time it snows. So you put the control inside so you can get at it and you can control it. There's also a remote control unit that you can put in a box upstairs if you want to. And the breaker panel obviously is going to be indoors also. So those are the parts that have to be inside. And the high temperature limit sensor should be in its own conduit as it comes back from the pavement. The aerial mounted sensor should be in its own conduit as it works from the sensor indoors. If you put these sensors and their wires in the same conduit as your heater cables or your mats, your system will not work. And it'll be against code. You can't put low voltage cable in low voltage in the same conduit as high voltage. And also, when those units switch off, it will kill the signal from the low voltage items. They won't work anymore. By induction, it'll ruin that signal. So they have to be in separate conduit. I have talked to multiple people over my 15 years here who call up and say, my system doesn't work. It's never worked. And it was installed correctly. And then after we go through about a dozen phone calls, you know how that goes. And we finally talk to the electrician and say, can you show me where the wire from the sensor goes and where it goes into? And invariably that sensor will go into the same wire that the non-heating leads are in. And that is why the system has never worked. So it's things like that. It's good to know that your electrician needs to make sure separate conduit for the low voltage, separate conduit for the high voltage, and the two never go in the same conduit.
Absolutely. And this is the finished project, and I think it looks very beautiful. I love the drain in the middle, so you're never going to have to worry about pooling water or anything like that. It's a great project. And you can actually see this project and a lot more. Anytime that someone does a really great looking project, we ask them, send it in. We want to see pictures. So we have some a project showcase page on our website, and this one has a video of the entire installation start to end.
Yeah, I think you can click on that. We could actually see it,
Oh,
can't we?
I think we could. I think that's why we did it. And I just forgot. Can I make this full screen? There we go. Can you see that?
Be able to. Yeah. Mm-hmm.
Okay, good. Still getting used to Zoom.
But we won't hear any of that groovy music.
No, we won't. I could do some like fun elevator music if you want.
But here we can see the base coat's down. That's why the drain is sticking up. Here we can see the conduit. That conduit right there is for the sensor. Mm-hmm. That is the junction box. And you can see those are together. You can see that sensor probe sticking out into an area between two of the heating mats. You can see how the mats are already pre-cut. They're just put into place. They're being tested with the meter. Make sure that you have the correct slope, getting the cold leads run into the conduit. And then here comes the paving truck. The conduit there for the sensor, notice located between two of the heating areas.
It's located between two, but it doesn't need to be dead center. I think that's important to mention as well. It can just be
Closer to,
in.
yeah, the closer to center you can get it though, the more the more centered it is, the more accurate it is. So that's just something you want to aim for. But you're right. So you can see here where they're dumping. This is how you don't have to use wheelbarrows. This is the secret. And a lot of people don't realize it until I actually make them watch this video. I said, please watch the video because this is how it's done. Oh, I never pictured that. Well, you wouldn't unless somebody shows you, you know? So you can see that the second layer is going on top. They're spreading it by hand. And here comes the next sets of cables, rolls. And you can see they're wearing gloves there because all you need to do is get one of those pieces of hot asphalt on your hand and you're going to regret it. And you're going to lose your shoes too. The first day you go out to work, you might as well consider them going straight in the garbage. But here you
Yeah,
can see
that's
them finishing it by hand. And now here comes the roller. The roller was back in the garage and now they're just going to roll over the top. You can see the electrician over there doing their work.
I think that's the thing. I think a lot of asphalt pavers don't picture this. Like they just
Mm-hmm.
can't picture it because it's so different than what they normally do. So I think I've seen that with homeowners get very worried because their asphalt guy is worried. And this is a great video to show them.
Because it really is simple once you see the secret,
Right.
you know.
And it always is funny to me. I don't know anything about asphalt. This is all I know. So to me, this is how an asphalt driveway is done.
Mm-hmm. Yeah. So yeah,
All right.
that's what's so great. Thank you for putting that video in there.
Awesome. So looking at so this is the actual cost of this project. So this one came out to just over $8,000. It's those snow melting mats. There's four, five, six, seven of those. Did that math right? Yes. There's the control, the aerial sensor, the plaque, as well as that relay panel as well. So again, that total just over 8,000 for the full coverage.
So if you, we had a question from Hamad beforehand about how much does an asphalt driveway cost? Um, what is the installation cost per square foot? Um, you can see the cost of our product there is included. The national average is about $8.75 per square foot for an asphalt driveway. So you can put those numbers together. Some places will be a lot less. Some places will be a lot more. But that's kind of a general ballpark as to what you're looking at of cost. So that's very good. Very good question. Thank you, Hamad. And he's got a couple more, but we'll continue on here.
Yeah, absolutely. We'll get to them. We love to talk. So this is going to actually show that tire track coverage, like I said, again, under the asphalt driveway. So for this system, again, the snow melting mat, 240 volt, but you can see the 840 square foot area is not getting fully covered. You're only going to end up with about 330 square feet of heated coverage. And this is going to be enough to get, again, in and out. It still makes the driveway usable. It still gives you that heating, but it's not going to be insanely expensive or insanely, powerful to run.
Mm-hmm.
So this is going to be just about 62 amps, 15,000 watts. The breakers are going to be shown. And then for this system, you are looking at about $1.75 per hour or $19 for roughly an average snowfall.
And if you look at this quote here, you can see two, three, four 240 volt breakers,
Mm-hmm.
which means actually 8 breaker spaces for those 3, and then another single breaker space for the control. So you're looking at 8 spaces for the heater and a 9th space for the control. So this is where I said at the very beginning, this is kind of where it all comes back together, is look and see how many breaker spaces you have. Because if you have 1 breaker space and you need 9, you're going to have a hard time getting this system to work.
A little bit. So this is actually the layout plan showing the tire track. So this is the area that we will be, covering this new addition to the driveway. And then the actual tire tracks, you can see again, the mats, the sizes, everything fully laid out.
Yeah, and if you see there, if you go back real quick, right there, if you look there, 1, 2, 3, 4 are the number for the rolls. Because of they're all starting there for a reason. And the reason is the power is located in a junction box right next to 1 and 4. So if you can kind of point out where that area is with your cursor, right over there's 1, 2, 3, 4. To the left of 1 and 4 is where the junction box was, right in there. So that's why they're designed this way. If the junction box was down at the other end, then we would obviously do a different design here. But we got the junction box fairly close to the house, as you can see there in the upper left-hand corner. You can see the drawing of where this actually is. It's fairly close to the house. So we did have to tunnel under the existing driveway with a boring machine down. I did this one too. So down under that driveway that's pre-existing, we bored under it and then back over, and we got the power to a spot right there. So you can see there, it's called out. This is how it's installed, and this is where the electrician would go. That's where that needs to go. I need to get my conduit there, and it's a great install. Easy to
Yep,
get in and out now.
absolutely. So you'll want to space the mats about tire width apart. Obviously, that can vary depending on cars, but is there a like an average?
Well, we just did this today out in the parking lot here because somebody said, "What do I need to make my spacing?" Usually, people will measure the center of their wheel to the center of their wheel,
Hmm.
and that will be the midpoint. And usually, that's around 5 feet. So if you get a 2 foot mat, you're going to have a foot over here and a foot over here because you want that in the center. So now you are 5 feet minus one. Now you have about 3 feet in between these two runs. And that's what it is. It could be if you're driving a semi over here, you're going to want to make it wider. If you're driving all going to be subcompact cars that are going to be narrower, you want to make sure that you measure that so you get your distances correct.
Absolutely. And then again, once it's laid out, the final pour of asphalt goes over. And then when the system turns on, it's just going to be those areas that will be clear, as you can see, just completely open where the mats are.
Yeah, and that way makes it easy to get in and out. And that people always ask, does that eventually melt? Yes, it'll eventually melt. The heat from that area and the sun will get it, and then it will. But look how clear that is. That
Yes,
area is clear. Makes it like much easier to get in and out.
it absolutely does. So looking at this, oh, look who it is.
Oh, this is the great big long one. I don't think we want to sit through
I
all
say I think
this.
this one is the long one. Yes.
Yeah,
So
yeah.
essentially, we can scroll through real quick and just kind of see essentially laying
Yeah,
out the
see,
mats.
yeah, that spot right there, that's where the electrician has been there ahead of time. So you can see that they've graded this, and now the electrician is there. He's already bent his conduit there at 28 seconds, or 29, and you can see where he's bent that, and those conduits are going actually into the surface. So what they did is they put the binder coat down, then he had already bent his tubes and laid them on top of the binder coat. Then they came and paved over the top.
Awesome. Yeah, that's a really creative way to do that. I think that was really cool.
And you can see that one lonely tube going in there. What do you think that one lonely tube is?
Could it be
That,
the sensor?
yeah, that one lonely tube is the sensor tube for the, because this is asphalt once again, right? We have to have that sensor in there.
So looking through, you can kind of see doing the pouring, laying out the mats. Same concept as before. I think we go over full coverage as well at some point in here.
The electrician's there putting them. So the electrician is there before and during and usually
During.
after.
Yes, and I think that that's often miscommunicated, so you want to make sure that the electrician is aware they need to be on site during the installation.
Now this
And
is a
there you go.
big, yeah, and then we move to indoors. So I mean that we really don't need to see that, but you can see there where the junction box is, and that makes a nice connection spot there. And this is what we want to see here. This
There we
is,
go. This is the
yeah.
better video. It's so cool. You can actually just see it melting away. It's very
Yeah.
awesome.
And see, you can see that extra wide section there in the foreground. We had a little extra of that roll. The thing is, you can never ever shorten the roll. You can never ever cut the heating wire. So all we did is we just doubled it up. And that's why there's that doubled up area there. You can see right there. So that's what that is. We had a little bit extra. So we just used that extra to clear that extra space.
Absolutely. Yeah, might as well use it up.
Mm-hmm.
So this cost came out to about $5,482. Again, it has those four mats, control, the aerial sensor, the plaque, and that relay panel.
Yep.
So do you have any kind of closing out tips for us when doing snow melting under asphalt?
Watch these videos and get them to your contractors, because just like you said, Lynn, until they actually see it and the light bulb goes off above their head, you can talk and talk and talk and talk, and they're going to, I don't believe it. I don't believe it. No, you can't. All you have to do is see the video. The most important thing is to watch the video, get them to your contractor, also get it to your electrician, because the electrician is going to say, oh yeah, I'll be there in the morning. No, you're going to be there in the morning 2 days in advance to get all this ready to go, because the asphalt contractors are not going to sit around and wait for you to bend conduit. They're not going to wait for you to manually string the cable back and forth, because some asphalt trucks are heated. They are actually, if you went up and touched the side, they are electrified, they're heated. Some of them are not. And the guys that don't have the heated trailers, they're going to say, we need to, either we're going to leave and go somewhere else, or you're going to need to do something to move this along. And sometimes that's why you'll see guys with the flamethrowers out there warming it up so it can be worked. So you know you're getting towards the end of the working period when you see the asphalt guys are using the flamethrowers to smooth that out. So be prepared. And once the asphalt guys are there, it moves pretty quickly. You're not waiting around. You're not killing time. You're simply, once they start, it's going. And you want to have all the preparation done ahead of time, because if it is, then you just go, okay, I'm done with this, move that. I'm done with this, move that. And you're just moving, like I said, a ballet, because one group's going to be going here, another group's going to be going there. One group's going here, another one's going like that. So very coordinated, but it's once you do a couple, it's just, no matter the size, it's still the same theory. So if it's a 2x2 area, it's the same theory as an area that's 60 feet by 60 feet. It's still the same idea. So just be prepared.
Absolutely. Some other things to think about, talking to the asphalt contractor about using duct tape on the edge of shovels to make sure that there's not sharp edges that are going to damage the mat, making sure that everyone's aware of where the mats will be and that they need to be kind of gentle with the factory splices and things like that. Just kind of, I think the biggest tip is make sure everyone's on the same page.
Right. There's a factory splice at the beginning where it goes from the non-heating wire to the heating wire. That area there in between is a splice. And that splice is where two pieces of electrical wire are spliced together. If you take that splice and you do this, you'll ruin it, because you'll break the mechanical bond. So that's why you never take a splice. The splice and the heating wire never goes in the conduit. And if you try to force the splice into the conduit, you're going to ruin the splice, and you're not going to be code compliant, because National Electric Code says that heating splice, since it does heat, cannot go in the conduit. So also there's a splice at the end, and that is a junction of the wire, and it's a termination there at the end. That, if you do this, you will ruin it also. So watch out. Don't step on the splice at the beginning, and don't step on the splice at the end.
Absolutely. So I know we got a couple questions ahead of time. Can you pull those up, Scott? I don't know if I have them right here.
Yeah. What is the relation between the and Hamad asked a bunch of these great questions. However, I'm not sure this pertains to asphalt, but I'm going to answer them anyway. What's the relationship? Because this may be an indoor flooring question, but that's fine. That's why we're here. What's the relation between the type of flooring you'll be putting down and the type of cable used? Some applications indoors are floating, and some of them are tile that are put down with thin set, and they use two different types of product. Also, if the product you use to melt snow in a driveway is not the same product you use to heat your floors in your bathroom, the floors in your bathroom are 15 watts per square foot. And in most cases, the outdoor snow melting is 50 watts per square foot. So it's completely different. Is a certain type of concrete recommended? I'm guessing this is for a concrete outdoor job. And if you're using concrete with mesh, with the product that we've just been seeing, the rolls with mesh, you have to use a concrete that has sub 3/4 inch aggregate, which means the rocks in that have to be 3/4 of an inch or smaller to fit through those holes in the mesh for that product. If you're indoors, what floor is the best to get a good heat transfer? Tile is the best because it has no temperature limits. Vinyl and a wood and that sort of thing, or carpet that has a low maximum temperature requirement. You can only go up to a certain temperature. Those are the poorer of the choices. You want a choice that doesn't have a maximum temperature. Tile can get much warmer. It can conduct much more heat. So those are the questions that Hamad had, and also the installation question, which we already answered. Mm-hmm. And then Rob is interested in replacing a current driveway with some type of low impact driveway material. What types of low impact driveway options have you worked with? Keeping in mind that the National Electric Code says you have to have a hard surface over the product, you can't use any of that lattice work. Like if you look at some pictures of low impact driveways, there's sometimes a concrete lattice where it lets the dirt and the grass grow into it. You can't do that because you have to have concrete, asphalt, or solid pavers above it. You can't use gravel. And so that rules gravel out. What we've seen is getting popular is a paver installation called permeable pavers, where you instead of using sand and that sort of stuff to set the pavers, you actually use stone that drains better. So we do have instructions that show you how to do an installation with a low impact driveway system composing of permeable pavers. That's the kind that we've seen. That's the kind that we know works. And it does pass all the rules about having a solid surface at a certain depth. So we do know that works. That's permeable pavers. And
wonderful. And I don't see any other questions, so we'll do a little bit of housekeeping here. Next month, we are doing a webinar on some installation tips for heated tile floors, rather. So feel free to join us for that. Again, it's a Thursday, 1 p.m. right here on Zoom. And we also offer daily trainings at least once a day, often twice a day, often hosted by me, hosted by Scott. And usually they're between 10, 15-minute long training sessions. Pop on in, learn a little bit more, and ask any questions you might have. And we do offer several services here, so feel free to reach out if you're interested in utilizing any of our services. We have measuring, troubleshooting, installation, and things like that. And through the end of the month, we are offering 15% off of our snow melting systems. So now is definitely the time to do it. Last chance before the cold moves in. So feel free to take advantage of that.
Yeah, keep in mind that asphalt plants close. When it gets to a certain temperature, they close, and then there's nothing happening after that. So please make sure if you're thinking about it, it's now or never, or at least now or next year, I should say.
Absolutely. And after this is over, we're going to send you an email asking about your experience during today's webinar. We'd love to hear comments, suggestions, especially if you have any ideas for topics for future webinars. Be sure to let us know. We want to make sure we're talking about what you want to hear. And if you have any questions, want a quote, if you need assistance, however we can help out, reach out, whatever is easiest. Call us, email us, visit our website. We have lots of information available on that website, so you can just probably browse that for days if you'd like. And again, reach out if we can be of any assistance in the meantime.
Yeah, that's where our videos are. So go to WarmlyYours.com and you can see all of our videos.
Absolutely. So thank you so much for joining us. Until next time, as always, stay warm
and be radiant.